You've seen it happen. That moment when you're working on something important and suddenly your whole screen goes blue. White text you can't really read, your stomach drops, you think everything's gone. Your files, your work, everything. But here's what nobody tells you about that blue screen. It's not your computer giving up on you. It's your computer making the smartest decision it possibly can in that exact moment. And the fact that it's blue instead of red or green or any other color, that was one of the most carefully thought out choices Microsoft ever made. In the next 20 minutes, you're going to understand why that terrifying blue screen is actually your computer's way of protecting you. And once you see how operating systems really handle catastrophic failures, you'll never look at a crash the same way again. Here's what's really happening when that screen appears. Your computer isn't broken. It's making a split-second choice between bad and catastrophically worse. Think about it this way. You're driving on the highway and suddenly your brakes start to fail. You've got two options. Keep driving and hope everything somehow works out. Or pull the emergency brake right now and deal with the consequences. That blue screen, that's your computer pulling the emergency brake. Picture this scenario. You're at Starbucks working on your laptop. You've got 12 Chrome tabs open. Spotify's playing your favorite playlist. You're editing photos in Photoshop. Maybe you've got a Word document open with an essay that's due tomorrow. Everything's running smoothly, and then something goes wrong. Not something small like an app freezing, something deep, something at the absolute core of how your computer operates. Everyone tells you that the blue screen of death means your computer crashed, but that's not what actually happens. What really happens is your computer detected something so dangerous that continuing to run would cause more damage than stopping completely. It's like if your smoke detector goes off. The beeping isn't the problem. The beeping is warning you about the problem. And this matters because what happens in the next millisecond determines whether you lose an afternoon of work or whether you lose everything on your hard drive forever. It's not just about that essay or those photos. It's about whether your entire system stays intact or corrupts itself so badly that it'll never work again. So let's talk about what actually runs your computer. At the center of absolutely everything, there's something called the kernel. Think of the kernel like the manager of a massive Target store during Black Friday. It's coordinating everything. When someone in electronics needs help, the kernel approves sending someone there. When registers need to open, the kernel makes that happen. When inventory needs updating, the kernel handles it. But here's the thing. The kernel at Target has supervisors above it, district managers, corporate, people who can step in if the store manager starts making terrible decisions. Your computer's kernel? It has nobody above it. It's the highest authority. It controls literally everything with zero oversight. The kernel is so powerful that it can access any file on your computer. It can control every piece of hardware. Your mouse, your keyboard, your hard drive, your graphics card, everything. It can even rewrite its own code while it's running. That's like if the manager at Target could rewrite the company's policies in real time while working the floor. And that incredible power is exactly why kernel failures are so terrifying. Here's what I call the authority problem. When Netflix crashes on your computer, that's annoying. But your operating system just kills the Netflix app and everything else keeps running. You lost maybe 2 minutes, no big deal. When Microsoft Word crashes, same thing. The operating system steps in, shuts down Word, and offers to recover your document. But when the kernel has a problem, there's no higher power to step in. The kernel is the highest power. It's like if the CEO of a company suddenly started making random decisions while having a medical emergency. There's nobody above them to say, hold on, we need to stop this right now. That's the nightmare scenario operating systems face with kernel failures. Pay attention to this. When your kernel detects it might not be trustworthy anymore, that's when you see blue. Because at that exact moment, your computer realizes something absolutely terrifying. The part of the system that controls everything might be compromised. Maybe a piece of hardware sent corrupted data, maybe a driver told it to do something impossible, maybe the memory got scrambled. Whatever happened, the kernel can't be confident its next decision will be correct. This matters because a kernel making wrong decisions is like a drunk driver with a license to do anything. It could accidentally tell your hard drive to erase your family photos and write random data over them. It could overwrite the files that make Windows even boot up. It could corrupt your tax documents, your music library, everything. And it would do this instantly with no way to undo it. That's why the blue screen exists. It's a hard stop, a complete system freeze, an emergency shutdown that says we are done here until a human figures out what went wrong. Now, this next pattern is particularly sneaky because most people never think about it. The blue screen isn't about protecting your computer hardware. Your laptop costs maybe $1,000. Annoying to replace, sure, but you could buy another one. Your data though, those wedding photos, that novel you've been writing for 3 years, that's irreplaceable. And that's what the kernel is trying to save when it triggers that blue screen. There's this thing I've noticed studying how computers work. The more power something has, the more dangerous its failures become. Your calculator app crashes, nobody cares. Your browser crashes, frustrating, but you just reopen it. Your kernel crashes, that requires a completely different response because the stakes are infinitely higher. Think about Jake. Jake's been using Windows for maybe 8 years. Every few months, he sees that blue screen pop up. Usually when he's doing something important, the screen appears, text he doesn't understand fills it, his computer restarts automatically, he loses whatever he was working on for the last 10 minutes, and Jake gets furious every single time. To Jake, that blue screen is his computer betraying him, breaking at the worst possible moment. He slams his desk, he curses at Microsoft, he tells his friends that Windows is garbage. But here's what Jake doesn't understand. That blue screen just saved him from something way worse. Let's say Jake's graphics card driver had a bug. It tried to write data to a part of memory it's not supposed to touch. Without the blue screen, that driver might have overwritten random chunks of his hard drive. It could have corrupted his file system so badly that Windows would never boot again. It could have damaged personal files in ways that no recovery software could fix. Instead, the kernel detected the problem in microseconds. It stopped absolutely everything. It captured information about what went wrong. It wrote that information safely to disk. Then it restarted the system cleanly. Jake lost 10 minutes of work, but his computer still functions. His files are intact. His system didn't eat itself alive. Now compare that to Emily. Emily also sees the blue screen occasionally, maybe once every few months when she's gaming or editing video. But Emily understands what it means. When her screen goes blue, Emily doesn't panic. She knows the system just protected itself from something catastrophic. After it restarts, she checks if there's a pattern. Usually it's a driver that needs updating, or maybe her RAM is getting old. The key difference? Emily recognizes that a system capable of detecting and stopping its own failures is more trustworthy than a system that just keeps running no matter what happens. It's like how a smoke detector that goes off when there's smoke is better than a smoke detector that stays silent while your house burns. Notice how Emily treats crashes completely differently than Jake? That's because she understands something fundamental. Computer systems fail. Hardware does unpredictable things. Software has bugs. The question isn't whether problems happen. The question is what your system does when they happen. Does it protect you, or does it keep running until it causes permanent damage? But here's where it gets really interesting. Why blue? Microsoft had to pick a color for this critical error screen back in the early 90s. They needed something that would immediately grab your attention, something unmistakable, something that couldn't be confused with normal computer operation. Red seems like the obvious choice, right? Red means danger, stop, emergency, fire alarm. But Microsoft didn't choose red. They chose blue. And the reason is actually brilliant. Back then, almost no software used a solid blue background for anything. Windows had gray, applications had white or gray, games had whatever graphics they wanted, but nobody used a full screen of solid blue. So if you saw that blue screen, you knew instantly that something was different. This wasn't Windows. This wasn't an application. This was the system itself speaking directly to you. Plus, there's a psychological angle. Blue is alarming enough to get your attention immediately, but it's not so panic-inducing that you freeze up completely. Red might make you think your computer is literally on fire. Blue makes you think something serious happened, but maybe I can handle this. It's the difference between a tornado siren and a car alarm. Both get your attention, but they create different emotional responses. And here's something else. Back when Microsoft designed this, most computer monitors would show black when they lost signal. A full screen of blue was unmistakable proof that your computer was still running and still communicating with the monitor. It just had to stop doing everything else to show you this message. Let me blow your mind for a second. Your computer is always making choices about what to display. When everything works normally, it shows you Windows, your apps, your desktop background. But when something goes catastrophically wrong at the kernel level, it faces a weird paradox. What can it safely show you? Remember, at this moment, the kernel doesn't trust itself anymore. It can't safely use your graphics card's advanced features. It can't load complex fonts. It can't render fancy windows or animations. It literally cannot do anything complicated because it might make the problem worse. So the blue screen uses the simplest possible display mode, just a solid color background and basic text characters. That's why it looks so primitive compared to modern Windows. It's not that Microsoft couldn't make it prettier. It's that at the moment of a kernel panic, the system literally cannot safely do anything more complex. It's like how during a real emergency, you don't worry about whether your outfit matches. You focus on survival. Here's what nobody wants to admit. Modern operating systems like Windows are unbelievably complex. We're talking about 50 million lines of code. That's more than it takes to run a Boeing 787. All of that code has to work perfectly, constantly, on millions of different computer configurations. Different processors, different graphics cards, different RAM, different hard drives, all made by different companies. And here's what makes this even more surprising. All of this has to work together in perfect harmony while you're running dozens of programs simultaneously. Chrome with 15 tabs, Spotify streaming music, Discord running in the background, your antivirus scanning files, Windows Update downloading patches, your RGB keyboard software making your keys glow, all at the same time. The miracle isn't that the blue screen happens occasionally. The miracle is that it doesn't happen every single day. And a huge part of why modern computers are so reliable is specifically because the kernel knows when to give up. It knows when to stop itself before causing irreversible damage. What's actually happening is something most people never consider. Operating systems are designed around a principle called fail-safe. This isn't about preventing all failures. That's impossible. Complex systems fail. Hardware acts unpredictably. Software has bugs. You can't prevent that. What you can do is make sure failures happen in controlled, predictable ways that minimize damage. The kernel is designed to crash when it detects fatal problems. That's not a flaw. That's a feature. Just like how the circuit breaker in your house is designed to flip when there's too much current, just like how your car's engine is designed to shut off if oil pressure gets too low. These aren't failures of the safety system. These are the safety system working exactly as designed. And once you see it this way, you can't unsee it. This is why Windows has gotten more stable over the years, even as it's gotten more complex. Windows XP, blue screened all the time. Windows Vista, too. But Windows 10 and 11, they're remarkably stable for most people. And that's because Microsoft got better at designing the kernel to detect problems earlier and handle them more gracefully. But when problems are too severe to handle gracefully, the blue screen is still there, still protecting your data, still choosing temporary inconvenience over permanent corruption. Here's another thing that happens during a blue screen that most people don't know about. When the kernel decides to crash, it doesn't just give up and die. It takes a snapshot of everything happening at that moment. Every program running, every driver loaded, the state of the memory, what the processor was doing, all of it. This snapshot gets written to a file called a memory dump, and that dump file is incredibly valuable for figuring out what went wrong. Microsoft engineers can analyze dump files to find bugs. Hardware manufacturers can use them to diagnose driver problems. Even you can look at them if you know how. So the blue screen isn't just protecting your current data, it's also collecting evidence about what went wrong so the problem can potentially be fixed forever. It's like how airplane black boxes record everything so crashes can be investigated and prevented in the future. And here's where things get even more interesting. Microsoft keeps evolving how they handle these catastrophic failures. Windows 10 introduced a friendlier blue screen with a sad face emoticon and simpler language. Windows 11 made it even cleaner, and if you're in the Windows Insider program testing pre-release builds, you might see a green screen of death instead of blue. Same concept, different color to distinguish between stable and beta versions. But the core idea remains unchanged. When the kernel detects it can't continue safely, it stops everything, protects your data, collects diagnostic information, and restarts your system clean. So here's what we've uncovered. That blue screen everyone dreads is actually your computer's immune system activating at the last possible moment. The kernel detecting a fatal problem that it can't solve while running. The system choosing to stop completely rather than risk corrupting your data. The color blue chosen specifically to be unmistakable and psychologically effective. The primitive display because the system can't safely do anything complex. The memory dump capturing exactly what went wrong for future diagnosis. Think about everything we just explored. The kernel's unlimited power and why that makes its failures uniquely dangerous. The authority problem, where there's no higher power to intervene. The difference between app crashes and kernel crashes. Why blue was chosen over other colors. The fail-safe principle that makes controlled failures better than uncontrolled ones. Modern improvements while keeping the core protection intact. All of these pieces work together to create a safety system that most people never appreciate because it only shows up during the absolute worst moments. The question isn't whether your computer is broken when you see blue, the question is whether you understand what just happened. Your computer detected a problem so severe that continuing to operate would risk permanent data corruption, so it made the hard choice to stop everything immediately, save diagnostic information, and restart cleanly. That's not failure. That's exactly how a well-designed safety system should behave. Just like how your smoke detector screaming isn't a malfunction. It's doing exactly what it's supposed to do. Emily understands this. Jake doesn't. And that difference changes everything about how they experience computer problems. Emily sees a safety mechanism activating. Jake sees his computer attacking him. Same blue screen. Completely different understanding of what it means. Here's the uncomfortable truth that ties all of this together. We want technology to be perfect. We want our computers to never crash, never freeze, never show us error messages. But that expectation is based on a misunderstanding of how complex systems work. Your computer is running millions of instructions per second. It's coordinating dozens of hardware components. It's managing hundreds of programs and processes, all on a platform that has to work with countless different configurations. Perfect reliability in that environment isn't just difficult, it's impossible. What separates good operating systems from bad ones isn't whether they ever fail, it's how they fail. Do they fail gracefully with protective measures, or do they fail catastrophically taking your data with them? Windows chose the first option. The blue screen of death is proof of that choice. It's the kernel saying, I detected something wrong, and I'm protecting you by stopping immediately. And now that you understand this, you can't unknow it. So next time you see that blue screen, you won't just see an error. You'll see a system that cares more about protecting your data than it cares about looking reliable. You'll see a kernel that detected a fatal problem in microseconds and chose the safest possible response. You'll see exactly how sophisticated safety mechanisms work at the deepest level of your computer, and you'll realize something that changes your entire perspective on computer crashes. That blue screen isn't your enemy. It's your last line of defense against something much worse. It's choosing temporary frustration to prevent permanent loss. It's being honest about its limitations instead of pretending everything's fine while your data corrupts in the background. Your computer's most terrifying screen is actually its most honest, most protective, most carefully designed safety feature. And once you see that, everything about how you think about computer reliability changes completely.